All right, one last video, one last reminder. When we're doing absolute value, when you're solving absolute value equations. For this, um, we had an example. I think it was something like 3x plus, let's just say 6. Ooh, no, x plus 6 is less than 7. Okay? Oh, let me make it something easier. Less than 9. So the first thing that we do is we want to isolate our absolute value system here like it's a variable. Everything in there we want to isolate so it's by itself. So we need to divide that 3. So then our x plus 6 inside the absolute value symbols is now the only thing we're dealing with. So then this says, and this means I need to know the value of x such that everything inside of here will be less, or well, everything inside of here will result in something that's less than 3 once we enact the absolute value symbols. So we know that on the inside, it must be whatever the result of this x plus 6 must be something that is less than 3 and greater than -3, because we know that an example value, -2, and example value 2, these would both result in 2, which makes sure that they fit inside of the -3 to 3 realm. Because we know that whatever it spits out is going to be positive. That means whether it's negative or positive, it needs to fall between a certain range so that my result is always less than 3, which means that we also want to make sure our negative results still don't equate to something bigger than 3. So if my result ends up being -4, that's going to be bigger than 3, which breaks my system, which is what I don't want. So let's say that my x value is equal to, or let's say this, my x value can end up being less than 2 and greater than 1. I made something up. I didn't do the math for this one. I would graph that like this, my 1, my 2, on my number line. And I would say that it doesn't include 1 and 2 because it's not an equal thing. It's just greater than or less than. So I would say it wouldn't include 1 and 2, which is why I have an open circle, but it would be everything in between. So I shade that space in between. You do need to shade the space in between. And then my notation would say 1 to 2. And we use parentheses when we don't include the endpoints. We use brackets when we do include the endpoints. Okay? All right. And if you had an example that was, let's say, let's just say this has to be greater than 4. Let's even say greater than or equal to 4. That means that this value in here, when the absolute value signs are activated, it must be greater than or equal to 4, which means my x value would have to be greater than or equal to 4 or less than or equal to uh, -4. I was like, what am I looking for? Because we know that less than or equal to -4, if we look at my number line, this is -4. This is everything less than or equal to -4, which could include -5, -6, all the way to -infinity, which means when I enact my absolute value symbols on -6 or -infinity, I would get infinity and I would get 6, which are much bigger than 4, which is the goal. Okay? And so if I said that this is my solution, right, to my problem, x is greater than or equal to 4 or less than or equal to -4, the way that I would write that on my number line is these are things that fall outside instead of something that's inside. I've got 4, -4. In this case, it includes the 4 and the -4 due to my greater than or equal to signs. And then I shade in everything on the outside, shade it in, shade everything in on the outside, shade it in to represent it's going to be all the points on the outside of these will be solutions to my equation. And the way that I write that is on this side here, this can go all the way to negative infinity, but it will stop at -4. And I do my bracket because it includes -4. This is what we use for an or relationship. You have an and relationship and you have an or relationship. This is an or relationship. It is not intersecting, so it's the opposite of intersecting timelines. In fact, they don't intersect, but we do want to we want to bring them into union. So we want to combine the points that are on opposite sides of each other. So this brings them into union with each other. A U. I don't need to emphasize that much, but it's going to be a U. And then I would say it includes 4, which is why I have my bracket. And then it would go all the way to infinity, which is why I have open circle. The open circle for infinity just means like, because infinity is an abstract idea, we don't have a number for infinity, it just means it goes on forever. We can't put a closed bracket on it because there isn't really a stopping point in that case, right? But we know that we are at least stopping at 4 and -4. This has more to do with the abstractness of the infinity piece. But that's how you would write that in notation.